In lesson 99, we will be doing more sequence problems. We'll start off with a little bit of review, but then we'll do some more sequence problems. And we'll also get formulas if we put only one mean in between a first and a last. So let's start off with a little bit of review. If I said find a common difference, right off the bat, that tells you we have what kind of a sequence, arithmetic or geometric. Everybody just shout it out. It's going to be arithmetic. And for A, can you just look at that and tell me what the common difference would be? So be 4, and somebody tell me how you came up with 4. There's at least a couple of ways you could think about it. Ben, how did you come up with 4? Okay, so one way is to say -3 plus what is 1, -3 plus 4 is 1, 1 plus 4 is 5, or what you just said you did, take 1 and subtract the one before it. 5 minus 1 is 4, 1, and 1 minus 3 is a plus 4. And second one, a little bit harder with those variables in there, but not too bad. Who can tell me what the common difference is on B? Lily Rose, what do you think?
6.
So 2x squared plus 6 would be 8x squared? So 6x squared. And I could either say 2x squared plus what is 8x squared, or maybe a little bit easier to say 14x squared minus 8x squared is 6x squared. So we know we can go both directions on it. Okay, if I say common ratio, then we know that these are geometric sequences instead of arithmetic. Ava, what would be the common ratio for number 1? -3. And you can either do that. 2 times what is -6? Oh, 2 times -3, but let's double check. -6 times -3, yes, that's positive 18. Or we could take any one of them, maybe the 18 divided by the one before it, and we get the -3. Okay, a little bit harder here with the variables thrown in. Probably easier now to take 1 and divide it by what came before. So let's say 8x to the 5th divided by 2x squared. And mean, what do I get there? 4x cubed, and then let's double check. Is 8x to the 5th times 4x cubed 32x to the 8th? I think we've got it. Okay, last two, and then we will reuse these on some problems in a few minutes. Okay, still geometric, it's still finding the common ratio with that. So let's take 1 and divide it by what's in front of it. Levi, what are you coming up with? So √2 times x is what we think for r right there. And let's see, if we take √2x squared times another √2x, we do get a regular 2 and we get x cubed. So that seems to work there. And number 4 here. Oh my. That one looks really like a challenge to me. I don't think I can just look at it and say first term times what is the second term. I think I've got to do the dividing in there. So let me take my second term, 2√6 plus 6, and divide that by my first term, 2 plus √6. Micah, is it okay for me to leave it like that? Why not? What do I need to do? So you're right, I cannot have a square root in the denominator, so I need to change it. What do you mean by multiply it out? What do I multiply?
Do 2 minus √6.
So I need to multiply numerator and denominator by the conjugate, 2 minus √6. If I have pluses, I'll put parentheses on those to help me keep it straight. So let's see. 2√6 times 2 is 4√6. 2√6 times minus root 6 is minus. The root 6's make a regular 6 times 2, so minus 12. Plus 6 times 2, minus 6 root 6. So it looks like my numerator is minus 2 root 6. Did I do that right? Check my work there. Okay, then denominator, I'm going to get the 2 times 2 is 4, and then I'll have minus 2 root 6 and plus 2 root 6. They cancel out. So I just need last times last. Plus times minus is minus. Root 6 is a regular 6. And so if I divide that by negative 2, I get root 6 for my common ratio. All right, let's continue then. Now let's find the 10th term in the geometric progression that begins x root 2 times x squared 2x cubed. But that is what we just did with number 3, right? So I am simply going to copy that and paste that much in here. So we've already done the work for R. Formula for a 10th term in a geometric progression. I need somebody who can help me remember, how do I do that? If I want the 10th term and it's geometric, what do I need to do there? Luca?
Would be x times r.
Because it will be a1 times r to the 9th, right? Everybody good with that? And a1, as Lucas said, is x, and r is root 2 times x. So I'm going to have that original x out there, and I'm going to have root 2 to the 9th. But I find it easiest when I have a square root to take it to the biggest even power I can. So I'm going to take the square root, I'm going to take the square root of 2 to the 8th times one more square root of 2 for that root 2 to the 9th. Everybody okay with what I just did there? Then I've got the x to the 9th and the x that I had out in front. So if I put my x's together, I have x to the 10th. 2 to the half to the 1/8 is 2 to the 4th, right? And what is 2 to the 4th? Everybody shout it out. So that's going to be a 16, and then I have this one extra root 2 in there. So my 10th term is 16 root 2 x to the 10th. Are we good with that one? Anybody at home or in class with a question though? Okay, next one. Let's find the 4th term of this geometric progression. But that looks like what we just did with that review part, right? 2 plus root 6, 6 plus 2, root 6. So let me go back and copy our work that we just did to come up with what R was. And so we said R is the square root of 6. So we've already managed to come up with that. Now we want the 4th term, and it's geometric. So help me out here. What's my formula for the 4th term if it is geometric? Isaac, what's my 4th term formula? And it's geometric. Remember what we need to do? A1 what? R cubed. So we write down A1 is 2 plus root 6. And then R is root 6 cubed. So if I take root 6, root 6, root 6, that gives me one regular 6 times a root 6. And then I just need to distribute that to the 2 plus root 6. So that will give me what? 12 root 6 plus root 6 times root 6 is a regular 6 times this other 6 gives me plus 36. So advanced sequences just because we get some that are kind of messy in them. Thumbs up, thumbs down at home and in class. Are we good with that? Continuing then, if we have just one arithmetic or geometric mean in between two other numbers. So we've got a first term and we've got a third term, and we are only putting one in between them. We want to come up with a nice little shortcut formula for what we need to do there. So let's suppose that before we do this in general with x and y, let's suppose I said, what is the arithmetic mean of 10 and 22? What would you do? If I just said, what's the arithmetic mean? How do you calculate that? This is review going back like to elementary school again. What would you do? You just add the 10 and the 22 and divide by 2, right? And what will we have? 32 divided by 2, so 16. Okay, let's develop the formula in general and prove our formula based on what we know of putting a whole bunch of means in between different things. So we want it between x and y, so x is my first, y is my last, and I want just one in between them. So that means x is a1. If it is arithmetic, that means the mean I'm looking for is a1 plus some kind of d. And y has to be a1 plus d plus another d, so a1 plus 2d. So if I wrote down this part right here that said, you know, a1 is just x, I could say y equals x, since that was my first term, plus 2d. Better figure out what d is, because I'm going to try to figure out this middle term here. So y minus x would be 2d. So d would be y minus x over 2. That means my arithmetic mean that I'm trying to find the formula for would be x plus d, first term plus d, and d is y minus x over 2. So if I need to add that d to x, I probably could use a common denominator. So I'm going to let that be 2x over 2. So then everything is over 2. 2x plus y minus x is x plus y over 2. And that's what we expected we should have as our formula if we just put one arithmetic mean in and we use our new knowledge about, oh, if it is an arithmetic sequence and we could put as many in as we want, what happens if we only put one mean in there? Now let's do the same thing for the geometric mean and see if we can find a formula there. So geometric mean, we're going to have x, and we're going to have y, and we're going to put one mean in between. But to get that middle term, we're going to take the first term times r. To get the last term, we're going to take that second term, x times r, times another r, so we have xr squared. So I need to figure out a formula for O. So if I start off with that last term y is xr squared, divide both sides by x, and r squared is y over x. So if I want just r, what do I have to do, everybody? Okay, I'm seeing a little bit of writing in the air, taking a square root, but not just taking a square root. We have to take plus or minus square root on that. So that means r is plus or minus the square root of y over the square root of x, and I'm not going to worry about rationalizing that denominator because I'm really after a formula for the mean, not for r. So now let's go back and figure out, okay, if we want a geometric mean. Just one of them in there between the first and the last, so now we're looking for that middle term. It needs to be x times r. So that means we need to take the first term times the plus or minus square root of y over the square root of x. So now, if I rationalize that denominator, multiply by root x over root x, I get a regular x that cancels with this x that I had over here. So I have plus or minus the square root of y times the square root of x, but I can combine those, and I think I happen to like alphabetical order. So formula for a geometric mean, we actually have two, and there we said we could do the pluses and minuses with, in a lot of cases there. So plus or minus the square root of x times y. So let's get those formulas written down for your reference, and I have no clue what formula numbers we're really on this year, but those are from lesson 99. If you want arithmetic mean, you add the two numbers and divide by 2. If you're putting just one geometric mean between two others, you could have either a positive or a negative in there, and you get it by taking the square root of x times y. So let me give you a moment to get that copied down before we go on. All right, so let's try out these formulas, and let's find the geometric and arithmetic means of 6 and 150. So we better label them. The arithmetic mean will be 6 plus 150 over 2. So 156 over 2, what is that, 78? Am I awake enough? Did I divide correctly there? And then let's also find our geometric mean. And we're going to have two of them. Positive or negative square root of 6 times 150. So positive or negative square root of 900. And what's the square root of 900? Quick mental math. Shout it out, everybody. So 30. So that would mean we could do 6, 30, 150, or 6, negative 30, 150. On the top one, I could simply multiply by 5 for the common ratio. On the bottom one, I'd be multiplying by negative 5 for the common ratio. So you see why we've got to have the two possibilities in there. And a couple more problems. You're going to start seeing a bunch of problems like this, and you've got to read them carefully. Sometimes they're going to ask how far it drops on the 17th drop, and sometimes it's going to ask how high does it go on the 17th bounce. Draw a picture. Don't try to shortcut on it, or you're going to mess up on which way do you need to set it up with what the first term is and everything. So for this one, I am going to start at 81 inches and just drop the ball. So the first drop is 81 inches. Then it is going to bounce up 2/5 of that. So my first bounce is 81 times 2/5. Then it's going to drop at 81 times 2/5. So that is the second drop. The first bounce is the same as the second drop. Then it is going to bounce up. It's going to take the 81 times 2/5 and take 2/5 of that, so 81 times 2/5 squared. And that will be the second bounce, but it will also be the third drop. So if I'm talking about drops or falls, which this one is, for the drops, my sequence is 81, 81 times 2/5, 81 times 2/5 squared, and so on. But if I talk about the bounces, my first term is not 81. My first term is 81 times 2/5. My second term is 81 times 2/5 squared, and so on. Since this one asks about drops, do you see the pattern? First drop is 81. Second drop is 81 times 2/5 to the first. Third drop is 81 times 2/5 squared. So sixth drop, who can tell me the formula for the sixth drop as you just look at those patterns? Come on, somebody's awake enough to. Which one?
81 times 2/5 to the fifth.
And let's just get that in decimal form, because I don't think 2,592 over 3,125 makes a whole lot of sense to most of our brains. So type that in, but be sure you put a decimal in there somewhere so it will give us the decimal form. Kyle, you have it already? 0.829, thank you. And let's see, our units are inches. But if we had wanted the sixth bounce, we would have had to have had 81 times 2/5 to the sixth. That's why I'm saying draw a picture so you can see the pattern and see which way you need it. Okay, one last problem. Positive geometric mean of two numbers is 8. So the positive square root, and I'm just going to call my numbers x and y, positive square root is 8. I mean, the other geometric mean was -8, but we're only going to use the positive 8 for this one. And then I want to know, let's see, the difference between the two numbers is 30. Does not matter if I do x minus y is 30 or y minus x is 30. This problem did not say use x and let x be the bigger of the two numbers. So maybe x is big, the way I've set it up, x is going to be bigger, but you could have set it up where y was your bigger one. So now I have a system, two equations, same two variables. What should I do to solve my system for x and y? What are your choices when you've got a system, and which one makes the most sense here? Michelle, what do you think? How do you want to solve that system? Root xy equals 8, x minus y is 30. It's a system of equations. Are you going to do elimination? Does that make sense to you, or something else makes more sense? And how would you set up elimination? Because I'm not sure I see how to set it up with elimination. Maybe what's a different choice for how you solve a system? Besides elimination, what can you do? You guys are not awake yet, other than a couple of you. Ryan. So what might you substitute here? Sounds good to me. X equals 30 plus y, or y plus 30. So let's change this x to y plus 30. And maybe before I do that, maybe I'll square both sides here so that I'm just looking at xy equals 64. Then I can plug in for my x, and I have y plus 30 times y is 64. So let's see, y squared plus 30y minus 64 is 0. Hoping that's easy to factor. Anybody see some numbers that will work for the factoring? Eli.
32 and
Say that again a little louder.
32 and minus.
So a plus 32 and a minus 2. Yeah, it looks to me like that should work for us. Which means y could be negative 32. That was the way I set it up. The smaller of my numbers could be negative 32. Or the smaller of my numbers could be 2. I have not found an x yet. I don't yet know x's. I know I've got 2 choices for my smaller number. So I have got to do case 1 and case 2. So if y is negative 32, x is y plus 30. So negative 32 plus 30 means x could be negative 2. So one possibility for my 2 numbers is negative 2 and negative 32. Other possibility for my 2 numbers, x is still y plus 30. So 2 plus 30, because this time I'm letting y be 2. So x could be positive 32. So 2 and 32 would be another possibility. Must circle these separately. Do not write plus or minus 2, comma, plus or minus 32. That doesn't tell me. Could 2 go with negative 32? No, it cannot. You've got to do it separately to show me that the positives could go together or the negatives could go together. Any other questions? All right, then I'm going to let you guys get to work here.